Step 5.3, Model-Based Clustering, Mixtures of Regressions. Let's now also look at a dataset with real data. We are using the vacation motif dataset from package FlexClust, and we're using the metric data which is contained there, which is the moral obligation, the NEP score, and the vacation behavior score. This contains missing values, and the functions in FlexMix can only deal with complete data, so we are omitting respondents where at least one of the variable information is missing. And for ease of interpretation, we're also rescaling or standardizing the variables for obligation and NEP. And what we want to do is, after we scale that, we want to fit the linear model. We want to predict the vacation behavior score depending on what did respondent state with respect to moral obligation and NEP score. So these are general scores for values and beliefs, and we want to predict what's their environmentally friendly behavior on vacation depending on their stated moral obligation and NEP scores. And we would want to identify either groups where this relationship is different, yes or no. So first we just fit the linear model without any groups, and this is what we would see, that the vacation behavior score increases with the moral obligation score and the NEP score, but overall the fitted model only has a multiple R squared of about 30%, which is not too high, which means that we're not very well able to predict vacation behavior depending on given those two other variables. So we look at what would be the result if we now fitted mixtures of regressions, and we would allow that there are groups where their vacation behavior depends differently on obligation and NEP. So we specify the same linear model. We use here the dot to specify any of the other variables contained in M where should be used. We're considering mixtures with 1 to 4 components. We're repeating the EM algorithm with 10 random initializations. We don't want to see output, and we increase the maximum number of iterations of the EM algorithm to ensure that it converges within all the number of iterations considered. And then we run the algorithm. That takes some time. So this takes some time to run. Once it's finished, we can use the function getModel to obtain the best model depending on some information criteria. By default, the BSC is used. So this gives us the best model with respect to the BSC. And we see this is a 2-component mixture model where most of the observations are contained in cluster 1, but there are also a few observations which are in cluster 2, and it took the EM algorithm 100 iterations to converge. Let's look at what kind of models did we fit. We refit again, and we look at the summary. So we see we have the 2 components here, and for one component we see that compared to the linear model, in particular the coefficient for obligation is now increased, and this also means that we are able to get a higher R squared value for that component here. And it also indicates that obligation is much more important to predict vacation behavior than the NEP score. Whereas for component 2, this obviously seems to consist of respondents where the vacation behavior cannot be predicted at all from the other answers they have given. So we are splitting here the respondents into 2 groups, where one, we are quite well able to predict their vacation behavior from other variables about values and beliefs, versus we have another group where this is not the case at all, where their moral obligation or the NEP score doesn't change their predicted vacation behavior. Let's look at what does this result mean. We are plotting 2 plots on one figure, so we are saying we want to have 1 row and 2 columns, and we are plotting first vacation behavior versus moral obligation, and in the second plot we plot vacation behavior versus the NEP score. and we're using the data set. That's the point size we want to use, so we want to have smaller points than usual, and the color we specify depending on where our observation is assigned to. So there will be 928 in one color, 47 points in the other color, and then we're adding the fitted lines for the two components. For where we are extracting parameter intercept and obligation, assuming that the NEP score has 0, and that's why we use rescaling at the beginning to that this makes sense. So this is the result for obligation, and then we do the same for NEP score. Here we are extracting the first and the third coefficient, so the coefficient of the intercept and NEP, and we set a moral obligation to 0. So these are the results. This is what it looks like. This is the fitted line for the larger group, and this is the fitted line for the smaller group.